Here we go. Chapter 3, Section 1, Solving Equations by Addition and Subtraction. From last year, this paragraph probably explains how you did it. It says equations are solved by using inverse or opposite operations. Addition and subtraction are inverses of each other. The main goal in solving any equation is getting the variable completely by itself. If we need to get rid of a positive 20, we subtract 20 from both sides, or do negative 20. If we want to get rid of a negative 4, we add 4 to both sides. We can also view it in this following way, and I'll talk about that in a second, but let me, before that, give you a quick review of what you probably did last year. If you had the equation x plus 2 equals 5. First off, we talked about this in Chapter 1, but let's talk about finding a solution to an equation. When I say a solution to the equation, you're trying to figure out what does x equal. Before, when we had an expression, and this kind of goes with Caleb back here, the difference between expressions and equations. If I have x plus 2, and that's all I have, do you know what x is? No. That's an expression. X could be 1, x could be 2, x could be 3, x could be anything. X plus 2 equals 5. Do we know what x is? Yes. Because once you throw that equal sign in there, and it equals an actual number, we can figure out very easily what x is. What number plus 2 is equal to 5? So obviously x must be 3. When it says solving an equation, that's what you're doing, trying to figure out what does x equal. Last year you may have had to have done this. Okay, to get x by itself, I want to get rid of plus 2. So minus 2 on both sides. Minus 2 and plus 2 cancel. X, bring down your equal sign. 5 minus 2 is 3. Y'all remember doing that last year. Let me show you how we're going to do it this year. And you don't have to show any of your work if you do it this new way. Let me explain like this. A plus B equals C plus D. From this last chapter, how many terms do I have there? 4. A, B, C, and D. Terms are separated by plus signs, minus signs, or in this case, equal signs. So A is a term, B is a term, C is a term, D is a term. The new method that I'm going to show you is once you move a term across an equal sign. Like if I wanted to move, for some reason, if I wanted to move my B over here, do you see that on the left side it was a plus B? If you want to move it to the right side, do you know what it becomes? A minus B. And you can just do it like that. So if I wanted to move my B from the left to the right, it just simply changes to a minus B. Let's go back. What if I wanted to move my A? All you would have, okay, B is left by itself because I'm moving A, so I have C plus D and then minus A. Moving a term from one side to the other side simply changes positive or negative when you move a term. We'll talk about tomorrow moving division and multiplication. If I want to move my C to the left side, I would have A plus B minus C is D. Makes sense. If you move a term, it just changes its sign. What if we had A minus B equals C? What if I wanted to move my B over here? So it would now be A equals C plus B. Could I write that as B plus C? Sure. Because why is C plus B the same thing as B plus C? You're adding, and you can add in any order, which means it's commutative. With that said, let's work some problems. Solve each equation. A plus 5 equals 4. Again, when you're solving equations, the main goal is try to get A by itself. Try to figure out what A is. And when I say by itself, here's my equal sign. I want to get anything that's over there with the A to the opposite side of the equal sign. And hopefully the whole moving thing will, anybody that didn't understand it before will understand it better now. If you want to work it the old way, fine. No problem there. So to get A by itself, I got to move my, what? Plus 5. So we're going to move it to this side. And it becomes, so we now have 4. And this, if you want to do it like this, you now have 4 minus 5. We moved it. So what is A equal to? Makes sense. Anytime you move a term, it just changes its sign. And you don't even have to show that. If you have A plus 5 equal 4, if you can think of in your head, okay, I'm moving plus 5, it becomes minus 5. I now have a 4, and I now have a minus 5, and I know that's A minus 1. So A equals negative 1 is fine. Next problem. 1/2 plus n is 11.5. 1/2 plus n equals 11.5. And let me explain something to you. I know that y'all can look at these and get the answers, right? But I do want you to know the process as well. There's reasons for it. What am I having to move? I'm moving the 1/2. Is the 1/2 a positive or a negative? It is a positive, so when I move it across the equal sign, it now becomes a negative 1/2. So 11.5 minus 1/2, and is 11. Any questions? This should be pretty easy to you. We're going to get to some a little bit trickier in a second, but this should be a pretty quick lesson. 27.2 equals h plus 45.6. A lot of people miss this first class. What am I trying to get by itself? H, the variable, right? I'm trying to get it by itself. Let's talk about that. I'm glad you said that. If I move the h over here, is it by itself? No, now it's over here with the 27.2. The best way to get it by itself is to move the 45.6. How do you move plus 45.6? You change it to minus 45.6. Correct? So you moved, you got rid of it. But let's look at it. You have 27.2 minus 45.6. Is that easy to subtract? No. You have two questions. This is a positive, this is a negative. Which do I have more of? Negative. How many more? How do you find out how many more? You subtract what? 45.6 minus 27. Why do you subtract in that order? The 45.6 is bigger. It's going to be easier. So that's going to tell you how many more negatives you have. Subtract, you get 4, 18.4 equals h. Why can I say h is equal to negative 18.4? Symmetric. Huh? That is two questions. Which do I have more of? See, I have more negatives, so my answer is going to be a negative. How many more do I have? Subtract the 2 to find out how many more. Good job. Well, I subtracted the two numbers to see which one or how many more I had. Yes, just a screen. A minus 5 equals 7. This was pretty easy. What am I trying to get by itself? Please wake him up. Raise your head up and watch. Okay? You really need to start watching. Okay? I don't want you in here getting extra. A minus 5 equals 7. Okay? I'm trying to get A by itself, so what am I moving? The minus 5. When you move minus 5 over, it becomes plus 5. You don't have to show me any work, guys. A equals, when we move minus 5 over, it becomes plus 5. So I have 7 over there. I have 5 more over there now. I have a total of 12. A is 12. That is all you have to do. One step for the whole lesson. The only time you might want to show your work is when you have like a positive and a negative like we had a while ago, to where you have two questions and all that, just to keep it straight. Do what? Hopefully you do it in your head with stuff like that. Yeah. If it's uglier, fractions, you might want to write fractions down. Okay, what am I trying to get by itself? N, so what am I moving? So it becomes positive 3. I have negative 8, and I now have a positive 3. N is negative 5. That's two questions. Which do I have more of? How many more do I have? There's more negatives. There's 5 more negatives. There's your answer. Last one of these. H minus 4.6 equals 2.2. What am I moving? It becomes positive 4.6, so if you want to write plus 4.6 and just mark it out. So H is equal to 6.8. Any questions? So, look at this next one. If you understand those, great. Hopefully you'll understand these as well. It says some are a little trickier because of the location of the sign. 7 minus m is 12. A lot of people is going to say the answer is 5. Is it? Give me an argument why the answer is not 5. Well, just look at it and tell me why is the answer not going to be 5. Because 7 minus 5 is 2, not 12. That makes sense. That's the reason I know the answer is not 5. And if you'll check yourself like that, once you get an answer, if you'll check yourself and say, is my answer right? You shouldn't miss any. Let me show you why it's not going to be 5. To get m by itself, what am I going to get rid of? The 7. Is 7 a negative number? No, a lot of people put this negative right here with a 7. That negative does not go with a 7. What's the negative go with? The m. That's a positive 7 and a negative m. So if I move positive 7, what does it become? A negative 7. So 12 and negative 7 is 5, right? What am I left with on the left side, though? Not just m, but negative m. Makes sense. And let me show you the trick here. This next step's really easy. If you have a negative m equals 5, the shortcut way of doing it, you can go ahead and just move the negative to the right side, and you get positive m equals negative 5. That's fine. That's not how I work it. I'm fixing to show you how I work it. 7 minus m equals 12. When I look at a problem like this, and it's not as difficult for this one, but if I look at a problem like this and I see that I have a negative variable, the first thing I do is I take that negative variable and I move it to the other side. Why do I move it to the other side? Because it becomes a positive variable. I no longer have negative m. Then I have just regular m. At the same time, if I'm going to move my m over there, in order to get it by itself, at the same time I'm going to take that 12 and do what with it? Move it to the other side. You see, then it's going to be by itself. So negative m moved to the right side becomes positive m. Positive 12 moved to the left side becomes negative 12. What's 7 minus 12? Same thing. That's fine. That's fine. I do that for a reason. When we start talking about variables, like with numbers out in front of it, it makes some of those problems easier. But however you want to work it, either way, for these you're probably right. I think the first method's probably a little bit easier.